this is exactly where we left off in the previous video. Still doing 2.1. I'm going to call this one B moving forward. So what we deduce is that our factors, we are able to figure out that we had -3, negative square root of 2, and positive square root of 2. But this time, what I like to do is investigate the fact that we had a negative leading coefficient. Now, right now, it probably doesn't seem like it's a big deal to you, but it's a huge deal. The reason why it's a huge deal is because think about from Algebra 2 that you had this end behavior concept. And what did having a negative leading coefficient do to your end behavior is it flipped everything. And the reason why it flips everything is because think about what happens when we did, like, I'm just going to give you an example, f of x equals negative x squared. That negative flips everything over the x-axis. Now, that's just a general statement as to why, when I do this problem, I do everything the same way I explained before, where I put -3, negative root 2. Notice I'm not paying any attention to the spacing here. Like -3 to negative root 2 is not much of a difference at all compared to the other one. But if you want to make a big fuss over it, go for it. So I'm putting a 0 at -3, a 0 at -2, a 0 at root 2. Any value to the left, I'm going to put these negatives in here. Any value to the right, I'm going to put positives. Remember, on the number line, to the left of zeros are negatives, to the right of zeros are positives. But with the negative leading coefficient, it's going to flip everything upside down. So I just put in a bunch of negatives. So as I multiply straight down, 4 negatives makes a positive. 3 negatives make a negative. 2 negatives make a positive. And 1 negative makes it negative. Again, think of it as negative times negative times negative times negative. Negative times positive times negative times negative. Negative times positive times positive times negative. Negative times positive times positive times positive. And the whole point of doing that is then you can go back to this statement and saying, oh, negative numbers are less than 0. So I want this piece and I want this piece. And we don't want to include the bounds because it's not equal to. So -3 to negative root 2 union root 2 to infinity. And that's the answer we want. And we can go back to what we did in the previous video and double check that that matched what we wanted. We're talking about this one right here, according to the directions. So again, pause the video, make sure you understand, or write a few questions down. Be ready to come to class with questions. You can email me, give me a heads up like, hey, I'm coming to class with questions. Things like that. So I am going to move on to the next page. So here's another one that I have to teach you one more thing, and I think you'll probably be good to go. First thing to notice is, do you have a negative leading coefficient? Oh, yeah, for sure. Now be careful, because sometimes the leading coefficient is hidden inside of the problem. I think the next example actually does that. And I also want you to notice that being squared is the same thing as writing x minus 2, x minus 2. So the reason why I need you to do that is, while it's true that x could equal 0, x equals -2, x equals 2 twice. So what I would prefer for you to do, this is my preference by the way, another math teacher might explain this slightly different, is write down 2 twice on the left side. Now there's another way around this, but I found the most success with students doing it this way. Now on your number line, you're only going to write 2 once. And again, I like going in order from least to greatest. It makes the most sense. Okay, so as I'm writing my zeros, maybe I'll change colors just to to make it bold, a 0 at -2, a 0 at 0, and then zeros at 2, and then to the left are all these negatives. To the right of all those zeros are positives. And then the negative leading coefficient means several negatives. So as I multiply 5 negatives, negative times negative times negative times negative times negative, I get a negative answer. Well, here I get 1, 2, 3, 4 negatives, so that's positive. Here I get 3 negatives, so that's negative. And over here I get 1 negative. And the reason why this happens is when you have an even power like this one, what it does is it just touches the x-axis and goes back in the same direction, touches the x-axis. And you might be sitting there and saying, well, why does that happen? Well, think about it for a second. Let me grab a highlighter and just think about, plug in some number for x in this equation. Doesn't matter. What's going to happen when you square that number? You're always going to get a positive. Now, the only exception to that is when x equals 2, because 2 minus 2 is 0 squared gives you 0. But that's why when you have an even power like this, it just touches the x-axis and bounces back in the same direction that you came from. So when we write the answer, let's think about what kind of numbers do we want? We want numbers less than or equal to 0. Those would be the negatives. And then the other piece is, can it be on the x-axis? Absolutely. So we want to include from -infinity to -2. And then from 0. Now if you wanted to, you could write 2 again, but it's going to bounce right off of 2 and go back. So you can actually just say 0 to infinity. And I don't know if you looked ahead yet, but the graph of that is already drawn right here, and you can explain that sign analysis, that's what it's called, by the way, is confirmed by this graph. Now I'll leave it up to you on how your explanation how the sign analysis is confirmed, but you know, write down something that talks about that we are below or on the x-axis at those values. Okay. So the next part, what if we just changed to be greater than or equal to 0? Okay, well that answer would have just been from -2 to 0. And then also, because remember, you don't want to use a interval notation when it's just a number, but it's also on the x-axis at x equals 2. Things like that. Now remember, I can ask this question right here in several different ways. Like, you know, if you look at another test, I could easily change the test by just changing the inequality, or just take away the negative, or take away the square, or change the square to cubed, or put an exponent right here. There's so many different ways and easy ways for me to change the problems around. So here's another problem that is slightly different. But what would make this easier to compare is if we subtract 3 over to get it equal to 0. And now what we can do is we can use a graphing calculator, whether it's Desmos or your actual TI, whatever, and find out where these zeros are. And maybe that's what I'll do next. All right, so it just jumped over here. And we can figure out these values, give or take. Remember, we like rounding to 3 decimal places. So -2.817. -0.338. 3.155. And then our graph looks something like this. Which, if you remember from Algebra 2, probably, we have that positive leading coefficient on degree. This is ringing bells, that's a good thing. So odd means opposite behavior, opposite end behavior. And then positive is up and to the right, down and to the left. If those are coming back to you, then that's a good thing. So now what you can do is actually plug in, like you can make the same sign chart, but at this point we're probably just wasting time because we can already look at the graph. Like if I put this on a test, you bet that I would let you just use your graphing calculator. But for practice, 817, 0.338, and 3.155. So this is just practice right now. Now I'll go back to green. Zeros, 0, 0, negatives to the left. There's no negative leading coefficient, so you don't have to worry about that. Positives to the right of 0. And then as you're multiplying, negative times negative times negative is negative. Well, we don't want that because we want greater than or equal to 0. Positive times negative. This one's a negative, and over here will be your positive. So what kind of answers do we want? We want the positive ones, and we also want to include those values. So we would say from negative 2.817 to negative 0.338 union 3.155 to infinity, which matches our graph up here. So I believe this ends the notes. Go ahead and hit pause. Make sure you understand how to get these answers, and then you should be ready for the homework on the next, well, yours is on a different page, but you should be good to go.